Here in this chapter we are transforming the triangle or rectangle, whatever shape we are displaying. We are basically transforming it in some ways, like changing its location or scaling the shape, rotating the shape, and translating it. And to do all that, we we basically use vectors and matrices. And in order to use vector and matrices, we need to use external library because OpenGL doesn't really have any. So we gonna be using this GLM library. According to tutorial, this one is kind of fine-tuned for OpenGL, so we can use this one. And this is the site OpenGL. This is the link, and we're gonna get the latest version 0.9.9. This is the latest, and we're gonna just download it. Okay, so which one is supposed to be latest? Okay, there it is. Tag release. This is a bit stupid. Okay, zip source code and another zip 7 zip. So our latest version should be this one. I think tag we have this 1.0.1 fix auto detection built-in. This one looks like it's new, updated like in 2024. Let's download the zip file and we'll see how it is. And it looks like it's working. We'll see. GLM folder, and we have whatever this is supposed to be. I don't think okay, well, GTC, BTX, and blah blah blah. What? GLM, this is this. Tutorial said something like we can just download it, copy the root directory of the header file into your include folder, and that's all we need to do. We can just copy the root directly into our project and we are good to go. This is my project folder and library, and we just need to copy this thing inside GLM inside our entire project file. We have it. We just need to copy this thing. This is the root directory into our project include folder. And there we have it, GLM, and you can see GLM. We are done, and we can just use it now. Let's start our Visual Studio. And to use it, all we need to do is just include it over here. Include glm.pp include glm glm. I think it was matrix trans trans glm gpc matrix transform, that is include glm, okay, not this glm gtc, and we have type ptr, what glm gtx type, we don't have type ptr over here, we do need to use gtc and type ptr.hpp. We don't have value of, so it's probably like building over here. Let's use it. Currently all I'm doing is, as you can see from the previous video, oh come on, why is it taking so long? So all I'm doing here is basically we have 4 of the smiley faces along with 4 of the containers with changing, basically varying colors of RGB W, basically red, green, blue and white, and it's taking the entire screen because I changed the coordinates to basically 1, which I'm gonna change it back to 0.5 right now, so I can make it like smaller or bigger accordingly. I can just directly do this, but if I scale it up then it's gonna be a problem. We want to be able to see it, so I'm gonna make it 0.5 for this set. There is, we need to find and replace, and quick replace, quick find. We need to find 1.0 and replace it with 0.5, and we do like 0.5. No, we don't do that. We don't. Can we skip? Alright, this is a bit of a problem. We don't need to do. Next one. Oh yeah, that is it. We can do this. All I'm gonna change is the coordinates, not the colors. So we are done. We have our coordinates back to 0.5, and let's try running it back. And we have it. And what I want to do is transform this and change the location. Right now it's in the center, so I want to change from center to somewhere over here, bottom right corner of the screen, and I want to make it rotate, obviously, because otherwise why would we even use matrix if we are not even gonna rotate this thing? That's the whole point of installing a brand new external library. And we also gonna scale it, so let's do this over here somewhere. We are activating shader, bring the image, similar for the texture. We're gonna do it after the texture, obviously, because we want everything to be load up. Transform there. Oh, I'm doing it over here for this as a like for testing, but kind of need to do this inside the loop because we want to rotate, so it needs to update it every frame. So we need to do it inside the loop. But here I'm just gonna glm matrix 4 and vector 4 maybe, and like what I'm trying to do is glm 4, yeah, trns transform would be equal to mat 4 initialize it to 1.0 and trans transform. Oh, we missed the R. Transform would be equal to, what we're gonna do is we're gonna change its location and then we're gonna rotate it. We are not gonna rotate it first, we're gonna change the location first. So we're gonna use translate, and we need ORM, the matrix we wanna transform basically, and what we need is the brand new one, the one we wanna basically translate it with. So I'm gonna use a vector there, vector 3, and I'm gonna give it location maybe 0.5. I don't know, 0.5, 0.5. Y should be negative 0.5 f and minus 0.5 x. X is positive, y is negative, so 0.5 and 0.5 and 0.0 f. And transform would be equal to, and now we first rotated it, and then we can like scale it, or we can scale it or rotate it. We first scale it and then rotate it, or we first rotate it and then scale it. I think I'm gonna scale it first. Scale. What? And to scale, we need to. Now I'm gonna just rotate. I'm just gonna rotate. Wait a second. Let me just scale. To scale, we need to transfer this one, and we are also going to use GLM vector 3, and we need to pass the uniform, which is gonna be, I think I'm gonna scale it by 0.2. No, 0.6. No, that would be too much. 0.2 with x, y, and I'm not sure if I'm doing it on z axis, but I'm gonna do it on z as well. It shouldn't really make a difference though, since it's just x and y, not the z. Actually, you know what? I'm just gonna make it 0 for that sake. I'm translating it, I'm scaling it, and then rotate it, and then transform, and we need the angle, on what angle we want it to like rotate, and we need to give it in radian. So let's give the angle GLM, and it's going to be radians, and we need to give the angle like the degree, like I don't know, maybe 5 or maybe 45. It's not going to be like this, but for the timing I'm just keeping that. We need to get like time and past time as the angle, but right now I'm just keeping it this, and like 3 for the axis rotation. This is gonna be, I'm gonna rotate it on z axis for the first time. So 0.08, 0.08, comma 1.0. Right now I'm kind of just trying to follow along the tutorial, and that's why I'm doing. So we have our translate, scale, and rotate. We don't need to do anything else. We should first scale. A scale basically going to make it bigger. Translate basically gonna add this vector with the this matrix, and then rotate is just gonna rotate this matrix at this angle every frame. It should do that, but since I'm not doing in a loop, so it shouldn't really make a difference. So I'm just gonna make it, I think, 45 or maybe 90. I don't know. Right now it's 45. On the z-axis it's gonna be tilted, so we're gonna be able to see the change. So we have this, and notice that if I run it now, it shouldn't really make a difference. And I can display this thing like std cout and transform dot x. Oh, transform dot x. Uh, transform. Oh, my bad. My bad. It's not a vector. It's a matrix. This is a matrix, so it's not a vector. So we don't really do that. Okay, so now we just need to, we have serial program already activated, so we just need to send the data to the, well, vertex. We need to send it to the vertex header so we can like use it. Why didn't vertex header have this functionality? Why like that extra support for, I don't know, UI? Vertex doesn't have it, fragment has it, it looks nice over there. This one doesn't have any coloring, then it's frustrated. Okay, it doesn't matter. So GL get, you know what, I'm just gonna directly assign it. GL uniform matrix 4, and it's a float and it's a vector. Location is gonna be GL get uniform location, and header program dot id, and the name is gonna be name is, that's not naming it, by the way. I'm gonna name it what? This is position, this is color, this is texture. Why do you even have this thing? I don't get it. We have a vertex color here. It's a vec4, and this is also a vec4. Alright. So we're gonna have okay, doesn't matter. I'm gonna have it plain form anyway. UNIFOM, and I need mat4. Now I need mat4, and let's call it transform maybe. I'm just gonna copy this name here. Alright, transform, and is it the same? Yeah, it is the same. And we get this transform here, and we're just gonna multiply this. Yes, transform. You know, in case of any spelling errors, I'm just gonna copy paste it to make sure I don't get any spelling mistakes, because I'm very bad at typing. And here count, we just send one, and false, and then the value which is GL value PTR, which is gonna be basically pasted, and that's it. And hopefully this would work. Hopefully I don't get any errors. Let's see. Come on. It takes way too long. And yep, it does work. And as you can see, it's over here. Location is shifted. If you can see it, location is shifted, and it's tilted 45 degree instead of 90 degree, and it's smaller. It's smaller because I'm scaling it. Scaling basically, instead of making it big, I just made it small, and change the location, make it tilted, and I'm gonna do it like every frame, so it's gonna be rotated. It will be like constantly rotating. First, let's try to make like And here when I'm scaling it, x-axis is and y-axis is. Here I'm just gonna not scale this, and let's see the result. Right now I'm not scaling this thing, so as you can see, I'm not sure what happened. Just completely thrown outside of the frame, and I'm not gonna be able to see it now, am I? Okay, well, this was a bad idea. So x is 0.2, so instead I'm gonna make it 1.0 maybe. Okay, let's see what happens with 1.0. Yeah, that is 1.0. With 0, it's like we made it, I don't know, make it invisible, too small, and remove it, I guess. Let's try to do, I don't know, how much should we do? 0.1 maybe. That's how small we want this thing to be. And notice that we are rotating on 90 degree. As you can see, 45 degree multiplied by 2 is basically 90 degree, and it's in a radian. So 90 degree on 90-degree angle, we have this thing like this, and faces are straight up, and this is a square, as you can see, square or a rectangle, whatever you want to call it, and do it on 45 degree, and let's make it a bit more bigger. Scale it. Instead of 0.2, I'm going to do 0.5. Scale it 0.5. Okay, so there we have it. So if you're wondering how the scaling works, so I'm going to give you a little bit of overview. So as you can see, if I do the value 5.5, which is clearly higher than 1, so as you can see, the result is come load up. As you can see, the result is higher than we expect it to be. We expect this thing to be restricted at 1, but as you can see, it's not restricted to just 1. We can make this thing as big as we want. And the reason why we can do this is because this is a brand new vector, completely new. Here I'm just creating a vector over here and passing this value as the as the as the input inside this scale function to translate this vector with this matrix, transform matrix. And that's why we are not restricted to just 0 to 1. We can literally just give any value we want. So here, if we do like 1 1 and 0, as you can see, and this is, we're gonna rotate it on z axis, and the location we are not changing it. As you can see, location does not changes, and if I don't rotate it on 45 degree or 90 degree, as you can